Hello everyone. In this tutorial, we are going to solve assignment 2, problem 4. So here we have to determine whether these functions are in big O of x squared. Okay, so the first thing I would love to share is we have to use this equation to prove it. The absolute value of f of x is less than or equal constant c, and it's gonna be the absolute value of g of x. So here g of x is given big of x squared. This is our g of x. So we have to prove whether this function f of x satisfies this condition, and then you will find a value of witnesses c and k. These values are not unique, so you might find a different value given here, different value from given here. So that's absolutely fine. You can get different values. It's not unique. So let's start with A. So we have 17x plus 11. You can easily see that it's a linear function, so it's absolutely, you can say it's a big of x squared, but you have to find the value of c and k. So let's do it. So the easiest thing to do is you can plot off everything to the highest term. So that means you can write it in this way. You have 17x, that's fine. You can broad this up to the highest term x, so that is you can write in this way. Instead of 11 you can write x, so that is it's equal 18x. Okay, so you just brought up this 11 to the highest term given here x, so that's 18x. So now what you can do, you can again brought this up to the highest term, so that is this, it's gonna be less than this. You can put x instead of 18, so it would be x, and here you have a x, so that's x square. Yeah, so that's it. You can see from here it's a big O of x square. So the value of c you find here is 1 from here, and these inequalities is true when you will choose the value k equals 18. So that's it. You got c equals to 1, k equals to 18, and you have showed that this function is big O of x squared. See, the value given here is different from mine, so you might get different values. That's absolutely fine, and it's satisfying this condition. So that's it. Let's move to the next one. The next one is x squared plus 1000. So yeah, your f of x is x squared plus 1000. So again, you can broad this up to the highest term. So you have the highest term x squared here. So you can simply do this x squared plus, you instead of 1000, you are bringing this up to the highest term, so that's x squared, so that is equal 2x squared. So that's it. You have got your value c equals to 2 here, and you can choose k equals to 1000. Yeah, k equals to 1000 root over 1000. from here you can see that the value of x is greater than root over 1000, so that's why k equals to root over 1000 here. So that's the next one. See here, it's a x and log x. X is a linear function. We also know that log x is a linear function, and it's true for log x is less than equal x when the value of x is greater than 0. So you can do this in this way. X, your log x is less than or equal x, and if you brought it up this one to the highest term given here, you can write it as x. So that's it, that's our x square. So you have shown that this function is big O of x square, and the value of c here, c equals to 1 and k equals to, you can choose k equals to 0, it will satisfy the equation. So that's it. So the next one, f of x equals to x to the power 4 by 2. So from here you can see it's a 4 and this one is 2. So you can easily say that no, it's not big O of x square. It's already x to the power 4. So for this, you cannot actually satisfy this equation, our main equation, f of x, the absolute value of f of x is less than equal c of g of x. G of x is x square here. So your constant is bound, like your c is greater than equal x square by 2, and you cannot find this value. So that's why you can say that this is not big O of x square. So the next one, f of x equals to 2 to the power x, you can easily say it's a no, it's not big O of x square, because if we satisfy this equation, 2 to the power x is less than equal c of x square. So that means this is bound by some constant 2 to the power x by x square, but you cannot bound it in this way. So that means this is not true. So 2 to the power x is not big of x square. So the next one, I hope you remember this one. This one is floor, and this one is called seal. So for floor, we take the value which the largest integer which is less than or equal x, and for seal we take the smallest integer which is greater than or equal x. So that means if you write it in this way, the value, the floor here will be x, that's the least integer here, and that's the greatest integer here, and the seal one will be x plus 1, because that's the smallest integer which is greater than or equal to x. So that's it. So this one, if you brought it up to the highest term, so that's gonna be our x, and this one is gonna be twice x, because if you put x over here instead of 1, it's gonna be twice x. So that's it. Less than or equal twice x, so that's equal actually to x square. So you have found c equals to 2, and in this case the value, this will be satisfied when the value will x will be greater than 1. So you can choose k equals to 1. So that's it. I hope you understand. Thanks for watching.